Okay, this is our design challenge one for the most beautiful machine. We are team 59 and we designed our machine with the requirements from team 60.
So Team 60's requirements were that there needed to be 3 to 4 wheels. It needed to be activated by a button. It had to move forward a certain distance and then move backwards to its original position. It had to resemble an automobile. It had to be small and aesthetically pleasing. And then just to clarify some more questions, we asked Team 60 about their aesthetics clarification, and they added that there must be symmetry in terms of the color and the design. And then for structural purposes, there must be no bent pieces and they should all be straight.
On our technical needs design specification, we took the customer needs of the number of wheels, an activation button, back and forth movement, automobile, resembly, the size, and the aesthetics of it. So we measured wheels with visual count. It had to be between 3 and 4, and we had a target value of 4. For the activation button, we had a count of the number of buttons you could use to actuate the machine. And the requirement was 1 and the target value was 1. For the back and forth movement, our technical need was motor actuation range as a percent with the Raspberry Pi. So the technical requirement would be negative 100% to 100%, and the target value was negative 50% to 50%. In the resemblance of an automobile, it was a visual evaluation, and we put that on a scale from 1 to 10. The technical requirement was 6 to 10, and we decided to get a target value of 7. For the size, we measured it in inches, and we said it had to be between half a foot and 1.5 feet. And we decided to go midway with 12 inches. And for the aesthetically pleasing factor, we also did a visual evaluation on a scale of 10. And we set that between 6 to 10 with a target value of 10. And for the system diagram, it's centered around the Raspberry Pi computing system. The computing system connected to the motor system, and the touch sensor, which ran off human input, would send a signal to the computing system, all of which worked off of energy. And then once the button was actuated, it would go through the computing system to the motor system, which would move the wheels, which would result in net movement of the machine.
So for our analysis of alternatives, our initial design, we had a tricycle design. This we abandoned because of stability issues, and we needed more space to accommodate the Raspberry Pi. Our second design, we moved to 4 wheels. We added aesthetics with a cannon and some colorful tubing. The tubing helps support the Pi and keep it in place. We put our touch sensor at the highest point, so it was really easy to use. And another additional benefit of the tubes was it was used for cable management. Our final design, we changed it to make it more symmetrical with tubes on both sides. We added more features to make it aesthetically pleasing, like the skull in the front. We kept the sensor placement where it was, and we tucked the cables for the motors underneath the Pi.
So in terms of our final design versus the design specification, for our target values for the wheels, we wanted 4. We actually were able to put 4 wheels on our final design. In terms of button activation, we wanted 1 button. We actually had 1 button on our final design. In terms of moving motions, the range was 50% to negative 50% to 50%. And according to our code, we were pretty much able to meet that like spot on. In terms of the visual inspection for resembling an automobile, our target value was 7, and also the other team, or we just gave the visual evaluation after we were done designing the final design, a rating of 9. In terms of the actual size, the approximate length of the final design was 12 inches. And in terms of aesthetically pleasing, the visual factor, we gave it a 10. And then here's a video of our demonstration. So as you can see, the robot was able to go, or the car was able to go forward and then move backward almost exactly to the original position.
That's our design. Thank you.